So we've got a question in from Sandy Gravel, and she asks, what is the bearing capacity of a soil? A very good question. Thank you for that, Sandy. So bearing capacity is a failure mode of soil, usually on a horizontal surface, an approximately vertical load applied to the soil surface, and if the load is high enough, eventually it will fail. So under a approximately vertical load, it can be inclined. That failure mode is called bearing capacity. So I have a bowl of sand here because you never know when you're going to need some sand, and this is a perfect illustration. So I'm going to use this sand just to talk a little bit about what bearing capacity is. So this is just an ordinary fine sand that's just relatively loose there. Let's just smooth off the surface. So let's imagine that I want to construct a big bottle of water onto this sand here. So the bottle cap could be my foundation. So the load applied to this sand, if I release the bottle, you get a little bit of compression of the surface of the sand. That is settlement. So not bearing capacity failure yet. The additional load on the foundation causes higher stress, higher effective stress in the sand that causes a little bit of compression, and that results in the settlement. Now in a sand, the settlement happens almost immediately, whether the sand is dry or saturated, because it has high permeability. Any water in the voids can escape and allow the soil to compress. It's different in a clay. If this was a clay, there will be a little bit of immediate settlement, but compression of the clay would take time. In a saturated clay, the additional load is taken by the incompressible water initially. It takes time for that water to flow out of the voids and for the soil skeleton to compress. That's why settlement takes much longer in a clay, and that's also important in bearing capacity, as we shall see shortly. So if I applied this in the middle here and then continued increasing the load until failure, if you look carefully around the sides, you should see that we actually get some heave. The soil actually comes up around the sides. So this is a failure mode now. This is more than settlement. All the soil has actually moved, and we've created a mechanism where the foundation is going down and this soil around the side is coming up. So we're left with a failure mechanism there. So what's the mechanism that's causing that, where the foundation's going down and the soil around it is going up? So let's explain that by going over to the flip chart, Brian, and let's have a look at bearing capacity. So we have a ground surface like that, and we are applying a concentrated, let's assume, vertical load for the time being. If that load gets high enough, the mechanism that we get is a shear failure mechanism in the soil. So we don't get compression failure of the soil. The particles are very hard and they won't fail in compression. The particles move around. Remember, it's a granular material. We've got particles that can move around, so they will move, and that's why this area goes down and we get a shear plane that goes all the way around and up. So the soil approximately, there are ways of looking at the shape of the mechanisms in detail, but just for the time being, let's just say broadly, the soil goes down here, around here, and then starts to come up. That's why we started to see the heave around the foundation as this went down. This pushed the soil all the way around, and we can consider this as a shear plane. So this soil here is not moving, but this soil is moving, so that creates a shear plane where that soil is pushed all the way around and up like that. And that is the critical failure mode under vertical load. These soil particles are free to escape, so they take the most efficient path out. It could also go this way as well. It could go both ways. What tends to happen is the foundation may tilt a bit during failure and it will tend to go one way or the other. So that's the mechanism. There are equations to calculate it. There are different equations for sand soils and clay soils. That is due to the difference in permeability that I was describing before. In a sand, this extra load immediately increases the effective stress in this soil beneath. So that affects the strength, because strength is dependent on the stress, because of the strength comes from friction. So you actually get an immediate benefit in soil strength by applying this load here. So because you get the compression immediately, you get that benefit of strength. So actually bearing capacities of sand and other granular soils is very high, and it's rare to get a failure in a bearing capacity failure in a sand soil. Maybe if it's particularly loose and it's a particularly concentrated loading and narrow loading, then sometimes you may have an issue with the bearing capacity. So working platforms is an example there. On a loose sand with a concentrated track loading or crane outrigger loading, you may get an issue with bearing capacity. And of course, it's going to be higher risk on a saturated sand. So if this was dry, it'd be very, very rare to get bearing capacity failure, but some groundwater here would reduce the strength. Bearing capacity is normally more critical on a clay. That is because you apply the extra load, but as I said before, this load gets transferred to the pore water, because water is incompressible. That takes the load initially. So that additional stress does not go into the soil skeleton, does not add strength to the clay. So in a clay, failure, once the load is applied, is most likely to occur in the short term, so almost immediately, because the clay has not gained any strength. Over time, the excess pore water pressure of the pore water resulting from this load will slowly dissipate as the water can flow slowly, very slowly, through the small pores of the clay. So that's why you get a slow development of settlement, but that's also why you get a slow development of effective stress and compression of the clay. So as time goes by, the bearing capacity of the clay will improve. So you can actually calculate that. You can calculate using the same method for sand, the bearing capacity of clay in the long term in terms of effective stress. So there you go, just a quick overview of what is the bearing capacity of a soil.